what is dimensional analysis? Dimensional analysis is essentially a way for us to convert one unit to another. So for example, not miles, if you wanted to convert kilograms to meters, for example, these are different units, we can convert these. If you wanted to not meters, pounds, my bad. If you wanted to convert kilograms to pounds, that's one example. If you wanted to convert meters cubed to liters to, I don't know, centimeters cubed to anything really, to convert meters to feet or feet to meters, all of these can go both ways, obviously. You can convert pounds to kilograms and kilograms to pounds, or if you just want to convert between prefixes, so milli, which is a prefix for 10 to the negative 3, can be converted to, no prefix, so a millisecond to a second. And of course, this can go vice versa. You can convert seconds to milliseconds. Now, the best way to explain how we perform dimensional analysis is to perform some examples. A pin is 3.45 centimeters. The first step is you write down the number that you have and the unit that you have, and you want to find the length in inches. Okay, you've identified that you want to go for inches, and they told you that 1 inch is 2.54 centimeters. How do you go about turning centimeters to inches? Well, it's actually really simple. 3.45 centimeters. You're going to multiply 3.45 centimeters by 1. Okay, you're going to multiply it by 1, but not just any one. It's a special one. This one is formatted in such a way that the old unit you have is on the bottom, is on the denominator, and the new unit you want is on the numerator. Why is that so? The reason you want to do that is you want to cancel out your old units. Okay? So I'll give you an example. 1 inch is equal to 2.54 centimeters. Okay, 1 inch is equal to 2.54 centimeters. So when you give a fraction, it's essentially like saying x over x, right? X is 1 inch and x is also 2.54 centimeters. They're the same thing. You made them equal. Okay, that's equal to 1. So you're multiplying 3.45 centimeters by 1. But what's special about this is that because centimeters is on the denominator, it can cancel out with the centimeters over here. And what you're left with is a unit that's only in inches. 3.45 divided by 2.54, we get 1.36. 1.36 inches, okay? So that's how many, 3.45 centimeters is 1.36 inches. Now, it's important to note that I put centimeters on the bottom. The reason I did that was because I wanted it to cancel with the centimeters over here. If I put centimeters at the top, it would not cancel with the centimeters over here. It would just be centimeters squared, and that would not work out. Also, another important thing to notice is that I made the larger unit equal to 1 in the conversion. So what do I mean by that? I didn't say, 1 centimeter is how many inches is in 1 centimeters, because inches is the larger unit, right? We can see here that 1 inch is equal to 2.54 centimeters. So inch is the larger unit, so I made it into 1. Now, it doesn't really matter which way you do it, but I find making the larger unit equal to 1 is a lot easier than the other way around, because I don't like dealing with decimal places. Moving on to the next question. A student entered a 10-kilometer race. Okay. How long is the run in miles and in yards? Okay, let's deal with yards first. Okay. 10 kilometers. Okay. Now we got to turn that into meters because the conversion rate that they gave us was in meters. How do we turn that into meters? Same method. Okay. Kilometers is the bigger unit, so I make kilometers 1, and I also know I want to cancel out kilometers, so I have to put it at the bottom. How many meters are in 1 kilometer? Simple, 1,000, right? Just knowing your prefixes. Okay, so now I've canceled kilometers. All I've got is meters, right? But I don't want meters, I want yards. Well, luckily here they have a conversion from meters to yards. It says that 1 meter is equal to 1.094 yards. So let's see, do I put meters in the numerator or the denominator? The denominator, right? Because I want to cancel out meters. Meters is the bigger unit, so I say 1 meter. 1 meter is equal to how much? Yards. Yards on the top because I want to convert it to yards. I want 1.094 yards, okay? And that will be our answer, and the final answer will be in yards. So doing the math, we get 10 times 10, 1,000 times 1.0. It should be around 10,900. Let's see. Yeah, 10,940. Yep. I can just find my. Okay, 10,940 yards. Okay, and that's how we converted kilometers to yards. We can go on to do another example. This time with miles. All right. So we have 10,940 yards, and we want to convert that to miles. Well, we put yards on the bottom because, like, once again, we want to cancel the yards later. And what unit do we want? We want it in miles. So we put miles up here. Miles is the bigger unit, so there will be 1 mile per every what? Per every 1,760 yards. We do that, and we get 40 over 1,760. 6.22. Okay, so we get 6.22 miles. So we know that 10,940 yards is equal to 6.22 miles. Okay, let's go to another example. The speed limit on many highways in the United States is 55 miles per hour. What is that in meters per second? Now this is a little bit interesting because this is not just one unit, it's a fraction of units. We have miles on the top and we have hour on the bottom. Okay, how do we convert this? Well, in this case we got to change both units. Okay, we got to change miles to meters and hours to seconds. Let's start with hours, but we could also start with miles. It doesn't matter in this case. So it's just up to you, matter of preference. I'm going to start with hours. Do I put hours on the denominator or the numerator? Before, I've always been putting it on the denominator, but because hours is on the denominator of our original measurement, we have to put hours on the numerator this time because, like I said, we got to make them cancel. So 1 hour, and what's the unit we want? We want seconds, so we put seconds on the bottom. How many seconds is in 1 hour? 3,600. Okay, 3,600 seconds. You can do this by simply thinking about there's 60 minutes in an hour, and within each minute there's 60 seconds, so 60 times 60, that's 3,600. Okay, but we're not done. We finished seconds, but we got to convert miles to meters. Miles is on the top, and because we want to cancel out miles, we got to put miles on the bottom. Miles is the bigger unit, so I make miles equal to 1, and want to figure out how many meters are in 1 mile. Well, it tells you right here, 1.61 kilometers. So kilo means 1,000, so we got 1,610 meters. Okay, what's great is the miles cancel, and you're left with just calculations you have to put in your calculator. You get 55 times 1,610 divided by 3,600. You get 24.6. So you get 24.6 meters per second. Okay, let's do another one. A Japanese car is advertised as having a gas mileage of 15 kilometers per liter. 50 kilometer per liter. Convert this rating to miles per gallon. Same as the previous question. It's a fraction of units, kilometers per liters. Let's get rid of these liters and convert it into miles. My bad. Did I say liters to miles? No, I mean kilometers to miles. Okay, so kilometers is going to be at the bottom because we want to cancel these kilometers out, and the unit we want is going to be miles. And it tells us here on the previous question that 1 mile is equal to 1.61. So miles at the top because that's the unit we want, and miles is the bigger unit, so we say 1 mile is equal to how many kilometers? 1.61 kilometers. Okay, liters. Liters, do we put it on the top or the bottom? We put it at the top this time because, like I said, liters is on the bottom in the original measurement, so we got to make it to the top when we do our dimensional analysis because we want to cross out liters. Okay, and what's the other volume metric we want? We want gallon. Okay. So gallon is the bigger unit, so we make gallon equal to 1. And how many liters are in 1 gallon? Well, it tells us right here, 3.78. You see that the liters cancel, the kilometers cancel, and you're left with miles per gallon. Do the math. and you get 35.22. 35.22 miles per gallon. Miles per gallon. Okay, that's how you do dimensional analysis.